Hello guys, welcome to the Blender beginner tutorial series. And in this tutorial we are going to look at rendering, how to render images and render out animations. If you have not subscribed, please subscribe for me, as it really means a lot to me, and give this video a thumbs up, like it, and any questions that you have, leave it in the comment section. Rendering is outputting a 3D scene into a 2D image or an animation movie. Outputting an animation movie in MP4 format or any other video playable format. I'll switch to the render tab and you will see rendering. So since we don't have any renders here, that's why we don't see anything, but when we render something we will see it here. So I'll just go back to the layout setting and we will try something out. So let's say this is the Blender default, the light and the camera and the object default cube. So let me hit 0 on the numpad. So when I hit 0, this is what I see through the camera view. So I'm come to render this part. So to render, you either come to render here. When you click render, you have render image and render animation. But before that, if you want to render this preview, you can just go to view and go to viewport render image. It will render it very quickly and you will see what you have on the viewport. Okay, I'll close it. And when you want to render it out really well with the light settings and the camera really well, you come to the render and you hit render image or you press F12 on your keyboard. So I'll press F12 and it will load. Okay, so it's rendered fast. And these are some information. This is the seconds it took to render. This is the frames. Since it's just an object, it's using only one frame, but if we had animation, it would have been more frames or something. So these are the render informations. But before that, let me go to the render output tab, the output properties, and let's see. So you see we have resolution, we have dimension, we have resolution. 1920 by 1080. This is the normal 1080p render, the normal video format, except the 2Ks and the 4Ks. But this is the normal HD, 1920 by 1080. And you see, if we can render something to pages like Instagram. Instagram requires square pixels, so you can type here 1080 also, 1080. And you see, check the camera settings, the camera shape. When I click, you see we got a square image. So changing the resolution here will change the camera's view. So let me reset it back to 1920, or when I press backspace, control backspace, it will just, let's try and see. When I hover the mouse here and press control backspace, it will just reset to the default value. And we have aspect, just like the what we demonstrated, the 1:1 or the square pixel. So when we have frames here, when it comes to animation, we have frames. We have the frame start and end, and every step that it will take to render. And we have the frame rate, which is 24 frames per second currently. So with the frames, I explained in the previous video that these are the frames, frame 1, 2, 3, up to 250 frames. You can likewise increase it to how many you want, depending on the time you are, the duration of your animation. But by default it's starting from 1. That's why it has 1 here. So if I click here, it will take me to 1, but you can change it that it will start from maybe 2 or 3 or anything. So you see it will start here, and this is where it will start to render. Even if your render starts from 1, it will render from this section where the 6th frame. So be careful there. So I'll just reset it back and put it to 1. No 0, 1. And we have the end. The end is just here, it's the same as this one, 370. We can increase it. Let me zoom in and you see we can just increase it here. That is the end. We have steps. The steps is within every frame, how many frames it should render within a particular time. So like it's from frame 1, let me say from frame 1 it should render frame 2, then frame 3, then frame 4. Like that's how best I can explain the steps. So for now, this is what you need to know with the dimensions. I explained that this is the resolution, the pixels, this is in pixels, 1920 by 1080 HD, and this is full. So let's say if I put this into half, it will render this one divided by 2. Okay, the same as if I render this in 4K. Let me see if I can get preset here. If I choose maybe this 4K, so now we have a 4K extra wide 38. This is not true 4K. This is 3840 by 1600 pixels. So if I use do this 50%, the percentage, if I do it 50%, it will almost look like a 1080 because I've divided this 4K times 2. No, it will be 2K rather. Sorry, 4K divided by 2 will be 2, so it will be 2K. So let me just reset it back and put it at my default 1080 by, this is not 1440, it's 1920. Let me type it in. Yes, by 1080. And let me the aspect should be 1 1, so 1 and 1. So this is our default render resolution settings. So from here, let's come to the output. So when you come to the output, this is where, with the file tab, this is where it will be located. When I click here and select, let me select my desktop. Yes, this is my desktop, and let me just type something in. Render stats. Okay, let me just save it. I'm saving it on my desktop, so I'll just accept it. So anything I render, it will go to that render thoughts folder on the desktop. Mind it. And we have PNG. PNG is mostly transparency, which when it's compared to when it's partnered with RGB alpha. But I can select here and choose a different format. If this is for the image section, we can render PNG, we can render JPEG, and all this, but mostly PNG and JPEG is what we use. And when we come to the video, when we are rendering video, we will do that in a bit. When we are rendering video, we choose either FFmpeg or we can choose PNG sequence. We will talk about that one too. So let's say this is PNG, and we have the color depths, which you don't have to bother yourself with for now. We have metadata, which is some information you like to appear on the render. You can just ignore them, or it's personally your choice. And we have post processing, you can just ignore them. So the dimensions and the output are the main important things. So I'll hit render again. Let's go to render mode and see if we have light. So we have some light on the scene, but before that, let me just add Shift A to add a plain background. Let me scale it S and scale it very big. Let me go to edit mode and E to extrude and Z on the Z axis. Okay, so we have this one now. Let me enable my gizmo keys and move it up a bit. Okay, so from the camera view, this is what we see, but we want to view it from maybe this side. So we press Ctrl Alt 0. You see, now we can do it, but the camera is breaking because we don't have it to lock. So you can come to view and we can lock camera to view, and now press N to push this back. When I press 0, I can just rotate it around. So let me just reframe the thing and put it here. Okay, let me give this one some color, just some random color. Okay, this is nice. Let's leave it like this and press render. So you can press render image or F12. So this is what we got. So with images, when I save like this, you can press the middle mouse to move around it. When I save an image like this and you want to save it on your desktop or on your computer, mind you, it's not saved when you have it like this. So you come to the image and you come to save as, and you choose anywhere on your desktop or any folder that you want. I'll choose my desktop and I'll just name it green, and I'll just save image as. So now we've saved it on our desktop. Let me visit my desktop and see. You see I have green here. I'll just on it and you see I have green. So this is the image from rendering image. Let me go back to Blender. And with the render engine that we are using cycles, eevee, sorry. We are using eevee to render. That's why it's really fast. So when it comes to rendering, if with the eevee settings, let me talk a bit about the eevee. Eevee is very fast. And turn them on and see what they will do with ambient occlusion. If I have another object here, the object will just give another light to the object, to the different objects, you see, and you will see. But since I have only one image, let me add another image for you to see what I'm talking about. I'll add another sphere and push it here. So when this is here and I add ambient occlusion, do you see the changes? Check the side shadows, you will see the difference here. So ambient occlusion off, you see, and on. So that is ambient occlusion. And we have bloom. When you have some extra light, it will produce some shade in, but since we don't have any other lighting, you don't see it very well. But we are using eevee, and since we are talking about how to render, you just press F12, and I've shown you the render settings. So what you need now here is, what you have to know here is just the render sampling. Sampling is what you add so that it will reduce the viewport noise. The eevee doesn't have so many, but when you go to the cycles render, you will see. So now I will switch this from eevee to cycles and watch what happens. When I switch it, you see you have noise in the scene. And cycles is path tracer. Path tracer is just try to mimic real life objects. So you see, this is for the cycles. And cycles is a bit slow with the CPU, but when you want to increase it, you can just turn on your GPU. And to use this GPU, come to the edit settings, come to the edits and preferences, and go to the system and choose CUDA. So if I choose my graphics card, this is what I'm using. I'll just close it and now it's GPU compute, so it will now use the GPU, but before that it was grayed out. So now it's using this. And like I said about the sampling, you see with the render we have 128 and the viewport we have only 32. It uses so many RAMs, it uses many memories. It really uses your computer memory. That's what I'm trying to say. Yes, so this is the sampling. You just add enough to clear the noise. If you render this one like this, let me press F12 to render, and you see with the cycles, because it's very big, it's now taking time to slow. I'll just pause it and pause the video, and when it's done I'll just come back. Okay, it's now done rendering. So this is with the cycles. So with the cycles, like I said, see it took more times. It took 57 seconds, and because this our timeline we forgot to check, let's check, it's on frame 4. That's why it's written frame 4 here. That's why it's written frame 4, and it took 57 seconds. And you see we have some noise here, this grains on the image. In these shadows we have some grains here. That is the noise. So if you want to remove this noise, that's when you increase the samples. So I'll just put the samples, render samples to, let's say, 250. When I put it to 250, or you can just check this denoising. You can use the viewport denoising, but I won't use that one. I'll just use the render denoising. So with denoising, it will remove this noise when we've increased the samples to 250. So this noise will be lost. We will try and see. And we have film, not from color management. Where is color management? We have color management. This is color management is after rendering the colors, how to use some custom colors to affect your images. So we have filmic, we have standard, and you don't have to really worry too much about this one. But with the look, you can choose contrast. This is where you can really play with it for now as a beginner. So you can play with this. You have medium contrast, you can choose high contrast, and you see what is happening in the viewport. So just play with this and see which one will best. It depends on the particular scene that you are rendering. So there's no rule of thumb to this one. It's just personal preference, how or which particular one you want. So for now, this is what you need. Okay, so we have the performance, we have threads, which Blender will detect it automatically for you, and we have tiles. So tiles are the boxes that was clearing for the render to happen. When, if you remember, I'll do it again for you to see. And you see we have 64 pixel by 64. With when we are using GPU compute, you can really increase this very high to, let's say, 256 by 256. It really helps with GPU compute. Let's put it this way and let's hit render again and see. So I'll press F12 to render. And you see, these are the boxes, 250 pixels. These are the boxes. But before that, it was just some small tiles that were just clearing. You see how it's clearing big. And the noise is really small because I added 128 samples and 250 samples rather. So you see, with every frame, with every box that will clear or every tile, it will just go 250 times. Check here before it switch to another sampling. And what again do you have to know? We talked about the time. This is the seconds. So after the time, it will record here, and this is the frame rate that we are rendering from. So this is the time remaining and the memory. So that's it. These are the tiles, and we choose 256, which are very big tiles, and it's very good or okay for the GPU compute. But if we were using just the CPU compute, we will use small tiles, or we will maintain the 64 by 64 pixels. So I'll pause the video and let it render. After I'll come back. So it's done rendering, and you see, as compared to the other one, you see the noise, there is no noise here, and the video is very clean. But since I don't have that one to compare, I'll have to re-render again. So when you are trying to compare renders, you can choose a different slot. Like I'll choose slot 2. Okay, so next time it will render on the slot 2, not the slot 1. Let's minimize it and render again. But with this time, since you now remember the GPU compute and the tiles, I'll reduce this tiles back to 64 so that you see what I'm really talking about. I'll add this one to 64. I'll do this 64, and I'll switch my thing back to CPU render. CPU, not GPU, CPU. Okay, so you see CPU is very slow, and we have the render. Let's do it 150 settings. The sampling render. So let's do it 150. Okay, so let me hit F12 and render it again, and we'll compare the two. Remember, we are using CPU render and 64 pixels tiles, so the tiles will be very small. Let me hit render. You see, this is really small as compared to the big ones, the 256 that we were using on the GPU compute. You see, and the tiles are really many, so it will render 510 tiles before all is done. And like I explained this one earlier, so I'll just pause the video, and after it's done, we will come back. Okay, so this one is also done. So now let's compare. This one, remember, we used the CPU and not the GPU with 64 tiles, so it took us 3 minutes and almost 30 seconds. But let's compare to the first one. This is the first one. First one was just 1 minute 46 seconds. The same image, but with different render engines. Different GPU and CPU computer. Let me say it that way. So, meaning GPU is really faster than the CPU. Like, that's what I'm trying to prove. Yes. Let me just minimize this. And you see, overall, when you put this one to eevee, it's just super fast. It will just take seconds. And when I press F12, bam, and eevee, it's done. But with eevee, this is just 93 frames, not even a second. It just took some frames. With eevee, it's not that accurate, but with cycles, it's path tracing, so it's really accurate. That's why people like cycles render for accuracy. But if you want to get away with some fancy renders and just fast renders, just use eevee. So that's the tool for you.